All right, welcome back, Calcsters. Hey, I asked you to finish a problem. All right, so let's check it out. F of x was root x, right? And we're working on the interval from 1 to 4. So f prime of x was negative 1 over 2 root x. Does that sound right to everybody? Okay, which is critical where? Oh, we're not finding critical numbers. What am I doing? Okay. Yeah. How do you find the average rate of change? The slope of what? F of 4. Okay, and let's see, that's 1/3. Okay, now what do I do? Yeah, I want to know when is the derivative equal to this. And this is where we left off, and I'm curious how you guys, I know you can all do this math. How would you solve it for x?
I multiplied by reciprocal.
Okay, Gerwin says cross multiply, I'm fine with that. 3 is equal to 2 root x. Divide by 2 and square it. 9/4. Now, what you always have to make sure you're thinking about. I'm expecting some value of c in which interval? 1 to 4. Is this between 1 and 4? Yes. Yeah, we're good. Mean value theorem, just as a reminder, because I think it makes a lot more sense graphically. You have a function that does this. It can even do something crazy like this. What is this? What's the slope of that line called? It's the average rate of change. Now, in this particular graph that I've just drawn, according to the mean value theorem, there's at least one point, c, or x, I call it x, where the derivative is equal to what? Not 0. That's Rolle's theorem. The average rate of change. Now, I can eyeball it. I think it's about here. I'll do it here in case Sam and Ava want to see it. I think it's about here, right? There's 1. That's a c value. They would call that c1. And then the other one looks like maybe here. C2. Now, your book, just so we're clear, I use X because I think it gets kind of muddled if we start using C. Your book wants you to find the C value. It's the same thing. We're solving for X because it's more natural. I could use C instead of X and solve the same problem. Okay. So we I mentioned yesterday that this was used in a court case, right? Yeah. All right. So what are the requirements for mean value theorem? What has to be true about the function? Has to be continuous and differentiable. Okay, so I don't need you to sketch this. Does mean value theorem apply here? Why? Yeah, it is continuous, but it's not differentiable because this little spot right here kind of messes it all up, right? Okay. All right, we have like a little sentence to write. Example. A truck driver, I'm just going to say driver because that's faster. A driver enters a toll road. And exits 4 hours later. Okay, they traveled 300 miles. Okay, so they entered a toll road, there it is. If the speed limit is 70 miles per hour, I want to know, did the driver speed? So there is a way to do this without calculus, for sure. But I want to make sure we can really drive through the calculus here. Yeah, like.
It was like a murder case, just a speeding ticket.
Yeah, it's a speeding ticket.
Oh my gosh.
Wait, they could
Maybe though.
math like I did.
They could have. We're gonna make sure we can see what the mean value term now. Okay. Now, there's not even going to be any real math to this. We're going to logic it out using math stuff,
How
though.
did they know for sure that it was 4 hours?
Because they entered the toll road, they took a picture of their license plate, and they took a picture when they left.
They did so much just to see if he was speeding.
Well, really, they do it for so they know where to send the bill for the toll road. They just take a picture of the license plate as you drive by. All right, here we go.
I'm never driving toll roads.
Man,
I'm driving around one.
could you find me the average rate of speed? Like, I assume this person probably sped up and slowed down and sped up. Like, it happens while you're driving. Could you find me how fast they went on average?
About
How?
280 miles.
Whoa, get that out of here. How do you find their average rate of change? Miles per hour. How do we find it, though? I don't have a bunch of miles per hour to add
You
up.
have miles and you have hours. 300 miles per 4 hours.
Yeah, they went 300 miles
For 4 hours.
over 4 hours. Now, if you want to see that math here, it's like saying, hey, they started at 0, right? That's their original distance, minus they went 300 miles, over they started at hour 0, minus 4. We get the same calculation. This is average rate of change. What does that wind up being?
What's 75.
75.
But it's okay to go 5 miles an hour over.
Immediately, I can see that they sped. Why? It's over 70, and because their motion is continuous, whether they stopped or not, like I can keep measuring it, there's no weird discontinuities in it. How do I know that at some point, at least once, they went that fast? Be more mathy, be more calcy. What guarantees that at least once they went?
I say not guilty.
Mean value theorem guarantees it.
I say not guilty.
Why? He obviously
It's
sped,
okay to
or
go,
she sped.
5 miles an hour over.
Yeah, but
No,
a lot
the
of
speed limit's
people-
70. What do you mean
a
it's
lot of
okay to
people
go?
Always speed, and it's like you go with the flow of the traffic.
What if somebody's just
How
like,
do you
what
drive?
if there's a high-speed chase
The speed limit.
Like from a
So
mafia?
if everybody else is going 75 and you're going 70, you're creating traffic. That's why you
He's a
go
leader,
with the
not a
flow
follower.
of the traffic, and then
A driver enters an empty toll road. There's no traffic to flow with. All right. Mean value theorem. Does it seem okay? Do you want to do some problems work with mean value, or do you want to step a little bit further into it? Step a little bit further? Okay.
Wait, I'm not done.
Okay.
So this was a court case? That is such a...
I feel bad for that driver.
I have a feeling it's probably been referenced a bunch of times. I don't know how many lawyers know the mean value theorem,
Yeah,
but
the worst lawyer though. Was he guilty?
I don't know.
What if they just drove and they stopped there, waited there, and then they just went back? Just imagine
They
like
could,
that,
but then why would you speed if you're just going to stop and wait?
I know, but then they were like, well, you came back at this time. And I go all the way this way.
Hmm.
How did they know that?
All right. Here we go. Mean value theorem, I guarantee it's going to show up on the AP test, like I'm certain of it. This will also show up. And this is where Calc gets pretty cool, pretty useful, depending on the context. Here we go. This new section, we're still in 4.3. I want to talk about how does one actually go about identifying, and I would just write ID if I were you, but identifying where a function is increasing or decreasing. Okay, this is going to be our job. Now, just so you guys know, for shorthand, increasing, if it's on a homework assignment or just in a problem that we're working together, I would do it here. When you actually write answers, it is increasing. You need to say the words. Decreasing is just going downward. Yep, as long as you know that it means increasing and decreasing, write it. Okay, yep, on a test. Now, check it out. I'm going to draw a function over here, and we're going to look at it, and we'll have to pick up some intervals. I want to see a function that does increase and does decrease. It's not going to be crazy. I'm just going to have it on a closed interval. Let's just have it do something like this. Looks kind of like sine. I'm cool with that. Or cosine, depending on how we move it. Let's say there it is from A to B. Now, I'm thinking we can probably all see sort of where it is increasing and decreasing. What would the derivative be right here? 0, because it's a what?
It's a critical number.
It's a critical number. It's where the derivative is 0. It's a maximum, if you'd rather. I'm going to call this C sub 1. And I'm going to call this other critical number C sub 2. Just so we can talk about it, and we'll name this function f of x. All right. I'm certain that we can all agree. I have it on my chin. I may as well just not wear it. Yes.
Is there a reason it's not FMC?
Yes. These are just any arbitrary x values I'm going to plug into it. Great question. So yeah, f of x is just, it could be f of theta. It could be whatever we want it to. Okay. Look at this. Tell me, where do you think that this thing is increasing? What's your gut say?
A to C1 and C2 to B.
So I heard A to C1.
C sub 2 to
B.
B.
Why would you say it's increasing there?
Because it's going up.
It's going up, right? Now, check this out. I think I agree with you guys. On this interval right here, it's increasing. And on this interval right here, it is also increasing. Which means on this middle interval, what's it doing? It's decreasing right there. Okay, we can all see it happening. I hope it's obvious. Same, if this had been pointy, it would have been the same, right? It's still increasing and decreasing. Differentiability, maybe it's not as huge of a deal right here. Okay. Gosh, how do we make this calcy, though? I don't believe you. We're in Calc class. So check it out. Let's make a little statement, and I think we're going to be able to reason it. Here's what we need to know. Put a big asterisk, something important. I'm going to make it a star. How do you guys draw your stars? Where do you start?
Up, down, left.
Where would you start your star?
3.
At 3?
3, 1, 4, 2,
5.
3, wait. 3, 1, 2, 4, 5.
3, 1, 2,
What?
4, 5.
3, 1, 4, 2, 5.
3, 1, 4.
2, 5.
Ugh. Gross.
How do you do it?
1, 3, 5, 2, 4.
What? 1, 3, 5.
That's hair.
If you look
Wait.
backwards.
Yeah.
three.
I
I draw it like 1.
Oh, did you see that short video the other day? Oh my god, it's so stupid. Somebody, you do them like that? I'm sorry, it's not stupid. That was the wrong word. Okay, there's a video the other day where they're like, hey, check it out. Some people draw their 8s like this.
Yeah. Uh-huh.
Does everybody start at the top?
Yeah. Who starts at the bottom?
I don't know, somebody might.
Yeah.
Okay, some people draw their 8s like this.
The circle?
2 circles.
I think mix them up sometimes.
This video the other day, they showed somebody that they're like, the gal talking did this, and then she's like, watch my friend do it. She goes,
Oh, yeah. What?
it's so weird. Like, everybody draws their B's like that, right?
No, I go down and then.
Down and then you do it.
Just like A, you do that first and you come back and cross it. I'm going to make it a habit of just writing in the wrong order. All right.
Everybody's gonna like.
Anyway, here we go. Make this important. Okay. We are going to let F. I can't do it. I'm trying, but it takes too much thought. Let F be differentiable on the open interval from A to B.
Whenever you say like on the open interval, I want to write that all.
Me too.
And I see that you like.
Differentiable.
Let F be a differentiable function on A to B. All right, there are 2 little pieces to this. Now, I get to use different colors. Unless you have a bunch of pens handy, you don't get to. But here we go. First one. If. Do you want to talk about increasing or decreasing first? All right, so let's consider f prime of x. And let's think about what it means. I'm going to take, and I'm going to draw on my graph. I don't require that you guys do, but I want to make sure everybody's eyes are up here. Pretend we're taking the derivative here. We're drawing the tangent line. Here it is. And that's on the increasing part, right? I'm going to draw a tangent line here as well.
Ooh,
I'm going to draw a tangent line here as well.
ooh,
All those slopes are what?
increasing.
They're increasing. Well,
Positive slope.
are they increasing? Slopes are getting smaller as I move to the right.
With a positive slope.
They're all positive, aren't they?
Yeah.
Is that what you said? Like even here, my function is increasing. What's that slope?
Like 0.
Positive. And here? And here?
Positive, yeah.
If f prime of x is what then?
Positive.
How do you say that?
Increase.
Greater than 0.
Ooh.
If f prime of x is greater than 0, then f is increasing. Really, really important here. Just like when we did the extrema, you need to move back and forth between them. To know if it's increasing, we check what? Of,
A rock.
no, we check the derivative. By checking the derivative, J3 is super important. We check the derivative and it tells us about f. Okay, you have to make sure that you're talking about f and f prime. How would we say the decreasing part?
Less than 0.
If f prime of x is less than 0, then f is decreasing. Okay. Now, again, this is where you're going to want to make sure you're really clear with your work. We're going to have functions that do a whole bunch of different things. We're going to go even further. And I'm just going to spoil something that we're going to see here pretty soon. You guys agree this is a max? My derivative changes from being increasing, positive, to what? Negative. If I see a sign change in the derivative, maybe that helps me find the extrema as well. We'll deal with that. 100% guarantee
Equals 0.
shows up. This will show up on the AP test a lot.
Okay.
Okay, let's do a couple problems. And then I think I'm just going to give you guys a bunch of time to work. Okay, so example. Oh, man. Cool. So the first one's not bad. The second one has 8 parts.
8?
8.
Let's just do the first one.
We'll do
You guys
both.
got 3 problems?
All right, here we go. I want to know where is f increasing, and you can just use up arrow, and decreasing. And I'm going to keep scrolling up and down so that we can talk about the other graph, just to make sure we can really see this. Okay, conceptually, everybody okay with saying if the derivative is positive, it's increasing, and we can see that that happens?
C.
Okay. All right, here we go. On A, this is actually a mathy problem. The second one's going to be a graph because the AP test loves graphs. Let's say we get a function f of, I was going to say phi, but you all just change it to x. Let's just call it f of x. You would too. E to the x, x squared.
If you do on the AP test, let x, or let, like, whatever that is.
You can.
theta equals x, then
Yep.
let you do that?
Yep. Remember, half the AP test is multiple choice.
So you get a 25% chance of getting the answer right.
Yeah, it used to be 20 because they used to have 5. It was A through E. And then they changed in like 2016. I don't know why.
That's good. They're
Good for
progressive,
us.
right?
I don't know.
Good.
I'll tell you, you need to guess. Like the hardest, I'm going to tell you, calc is kind of hard.
Kinda.
Like, do you think it's harder than pre-calc?
No.
You don't think so? I don't think
I don't
so.
remember pre-calc.
I barely. The only thing harder about pre-calc was like learning the trig stuff, but overall calculus is harder.
See, I like math. I'm pretty good at math. Personally, I think calc is easier because it's all the same. Like, there's no bouncing around with stuff.
I like how calc is repetitive.
I
Yeah,
don't
like we're
geometry.
just doing derivatives for the last 5 months. It's all
I
that.
like derivatives.
All right. Anyway, the hard part for me for calc is conceptual stuff can be challenging, which is why we're talking about it at such length, and maybe it's repeating. But then the algebra is the hard part of calc.
What?
The algebra is the hardest part of calculus. Okay.
Is it
Now,
really?
The trig is.
oh no, the hardest part of the AP test is time. 100%, it's time.
Wait, how much time?
4-hour test.
When is it?
2 hours
May 9th.
for each section?
You will do 45 or 50 minutes with multiple choice with a calculator. You'll do 45 or 50 minutes multiple choice without a calculator. You'll do 4 problems without a calculator in 60 minutes. The like free response word, like write them out. 4.
In 60 minutes.
And then 2 in 30 minutes. So we'll build up the speed as we get going because some of your, like the tests that you've had so far, have they seemed long?
Yeah, I like
Yeah, the speed is the hardest part.
This
But let's,
part was like really long.
I bet they're my tests, I would assume.
Yeah, but they were like really long. Because I didn't like understand.
Okay, let's knock it out. Okay, looking at this graph, where does it change from increasing to decreasing? On this one. At this point C, right? And what is C? It's a critical number. My function can change from increasing to decreasing at critical numbers. If I want to know when is this thing increasing and decreasing, what do you suggest we find then? Let's find the critical numbers. How do you do that?
Take the derivative
Okay.
and make it 0.
Or undefined, but yep. Let's take the derivative. F prime of x equals, Shane, spit out this derivative for me.
E to the x,
Okay.
and then x squared.
Try it again. Oh, you do it backward.
Yeah.
Okay, never mind. E to the x squared. This.
Plus e to the x, 2x.
Okay. Yep, that's okay. Is this the same thing? Do your own derivative. Does everybody else, other than Shane, do first times the derivative of the second?
I only do that
I do it.
because,
I
like,
change it every time.
You don't do it. You do it first. You do this times 2x. Why do you do it backward?
because the quotient rule, like you do the derivative of the top, so I always do first and then second.
I do
Derivative
the
of first
first.
and then second. That's how
Okay.
I
Okay.
learned it at the same time.
No. Wow.
I
What?
wasn't here.
Okay. That's okay.
I wasn't here for
All
the
right.
trig stuff. so-
This drives me crazy because it looks differently than I would do it, but that's okay. We need to solve this and set it equal to 0. Now, let's make sure we can do this. What would you factor out? One more thing.
E to the XX.
X e to the x. And your e to the x works, Tristan, you're good. What leaves behind what? X plus 2. Okay. Now, this is always a weird situation. How many factors do you see? I don't agree. There's 3 of them.
X.
X is a single factor.
E to the X.
E to the x is a factor. And x plus 2 is a factor. There's really 3 of them. But let's go ahead and check it out. I think I can see my critical numbers.
0. -2. And
Can I ever make this one 0? No, I can't do it. Here's my 2 critical numbers. It happens at 0 and 2. 0 and -2. Okay. I do this next part differently than your book. Ava and Sam, if you're watching this, gosh, I hope you're watching this. Your book looks different. Okay. For this, I need to check. I'm going to make a number line. Okay, and on this number line, I'm going to put the critical numbers. Here's 0, and here's -2. Now, if I want to know if it's increasing or decreasing, I just need to know the behavior of f or f prime. Which one's going to tell me if it's increasing or decreasing? F does? F prime's going to tell me. So, because we are going to start using more stuff, I'm a huge jerk about this. We're going to plug values into what function did you just tell me? I need you to write f prime here. Need to. Now, don't write this one, but I need you to do this because later we'll do this. F double prime. We will use both of them. It is imperative that you can differentiate, poor choice of words, that you can distinguish between the two. Right? Because different. Okay. All right. I just need to know the sign of the derivative here. Pick an easy number. Ooh. We're going to use better ideas. What's the easiest number you can plug in any of these three intervals? 1 is the easiest, right? And I'm going to plug 1 into what function? F prime. Check it out. 1 times e is positive, and that's positive. Don't care what the number is, all I care about the sign. What did we just say it was at 1? I'm going to write positive underneath, and I'm going to write an up arrow. Okay, what's an easy number to check between -2 and 0? -1. Now, at this point, I'm just going to hold on a second. I don't think I need to. Why do you say that? Okay, 2 ways we can do it. We can check -1. I could check it. Let's see. This is the easiest version to plug into. I could plug into either of them, but this one I can think about. Let's see, that'd be a negative. E to the -1 is a positive, and -1 plus 2 is a positive. What's it going to give me? A negative.
That goes down.
Okay,
Go down.
I'll tell you, I knew that.
Go down.
I knew that before. Nope, even if this wasn't a problem. The critical numbers are the whats of the derivative. The zeros. This 0, either of them showed up how many times? So this one showed up, I guess, 0. How many times did this root show up? Once. It has an odd multiplicity. When you think back to, if something has an odd multiplicity, did it cross the x-axis or did it touch and turn? I can see what it did. Did it cross or did it touch and turn? It crossed. What's the multiplicity of this one? How many times did it show up? Once. So what's it going to do? Ooh, try again. It's going to cross. Okay, and then this is going to drive me crazy. I mixed this up the first time. I thought I could get by without changing it. I want my plus negative stuff right here. Yeah, I want it on top. Only so that later when we do f double prime, I can do the same stuff here. Okay. I honestly don't do the arrow normally, but it's good practice for you. Up, down, up. Okay, so the true question was, hey, when is f increasing and decreasing? So let's answer that question. Can you tell me where it's increasing? Like, just to make language nice first, we have left, middle, and right intervals.
Left to right.
Left and right intervals is increasing. Everybody cool with that?
Yeah.
Okay, so let's write it out. Here we go. F of x is increasing for all x in 2 different intervals. How do you write everything to the left of -2? Negative infinity to -2. Do I touch -2? So that's a weird question. It's 0. At 0, I wouldn't say it's increasing anymore. I'm not going to touch it. Union, what? Okay, boom. Okay, this next part, it's so tedious. Why? Because, how do I know f is increasing there? And what was, no, we didn't check the critical number. What's true about f prime in both of those situations? There you go. You're going to want to write it. Yep. F of x, and I'm going to shorthand it because we're doing a homework right now, is decreasing for all, I'll say, for the set of x such that,
You have 2 answers?
well, increasing and decreasing, yep. Where is x decreasing? -2 to 0. You can write it either way. I like the mathy notation. It's shorter. Why? Ooh, not f of x. F prime of x is less than 0. Now, again, we're going to hit this in a subsequent lesson. Imagine a function that goes from increasing to decreasing. Check it out. I'll even just do it here. I'm not going to graph it nicely. Here's -2. It was increasing, and then it changed to what? What do you think I just found on my graph? Not necessarily 0. It was a critical number, but more specifically, it was the extrema. I just found a max. What do you think is going to happen when I go from a decreasing function going downward, all of a sudden it goes upward instead? You're going to find a min. Okay, we will use the heck out of that. Does this problem seem okay?
Yeah.
Yes? So let me go ahead and just pull it up here. Will somebody read me the function? F of x. Whoa.
Equals e to the x.
I can't read that.
I read that email.
What is going on here? It wasn't important. What?
That's the whole purpose, though.
Okay, that does it there. What is going on here?
Reload the page.
Like, you can't feel it.
I know, why did I do
That's so sad, dude.
my free Calc is where I started getting mad.
That's so stupid though. I was like, yeah, but they're deaf. They're still stupid.
Weird. All right, what was the function?
The function was e to the x times x squared.
Just process it.
Okay. Here's the function, and Chanel, we're gonna look on this thing. You asked why it's not equal to 0. This is the maximum. Okay, are you cool with that? Okay, at this point, if you were to draw the derivative, what would its slope be? 0. The value of the derivative is 0, right?
Yeah, that's why I thought it'd be.
So here's the thing though, if this is 0, if I had my tangent line as 0, is that increasing or decreasing? If the slope is 0. The slope of 0 is increasing, it's getting bigger? It doesn't do anything. I don't want to say it's increasing there then. I also don't want to say it's decreasing.
It's stagnant.
It's 0. I'm not going to include it as increasing or decreasing.
Did I use that word right?
Yeah.
It's stagnant.
All right. Uno mas.
You know,
And
maps.
you're going to want to turn your page. Because we get to draw a graph. You're going to want to write really small. Or get a new page.
I need a whole page.
Okay. We're drawing a graph. And it doesn't have to be perfect, but it's got to be pretty good. Okay, my graph goes on the y scale from 1 to -1. Okay, on my x scale, I'm going to count out to 6. 1, 2, 3, 4, 5, and 6. And apparently I had more than I needed. I don't need all those. Let's do 1. I'm actually not even going to include 1. If it's there, I'm just going to assume it's jumping by 1. You can have 1.
What do you mean?
I made mine look
Survived an hour.
God, that was a quick hour.
I know.
What was?
No.
We've been here an hour.
Been here an hour?
Yeah.
I feel like we just got started.
Right? All right. Here's what we're going to do. I have an open point at the origin. 0, 0, open. Okay. And then I go down to 1, -1. The next point that I get is at 3, -1. Then I go up to 5, 1. And 6, 1. Okay,
I'm 6'1".
they're all segments.
I'm not kicking you. I know how it feels.
Well, then who just touched my butt, Adrian?
I was stretching. I didn't even feel it, to be honest.
What is that? 5
Yep, this is the point. 6, 1. 5, 1. 3, 1. Or 3, -1, I'm sorry. 1, -1, and 0, 0. Yep, they're all straight segments.
When you play basketball, man, you mean
Yes, we need that. I mean, you can't like outshine Lily, but like
Yeah, but you can try.
you can try.
All right, everybody have this graph.
Lily bangs things all day.
Okay, underneath we're going to go ahead and include a title. We're going to say, here is the graph of f prime of x.
That's the prime.
This is the graph of f prime of x. Okay. Which means we're going to ask a whole bunch of questions about f. This is its graph. Here we go. All right, first one. We'll just tackle them one by one. I want to know, this is an easy question, I hope. What is the domain of f prime of x? Instead of x such that, I'm cool with that.
0 is less than
5.
x is less than or equal to 5.
Five? You can do either one. Keep yours, Lily. I'm going to write it.
6. Someone said 5 and then
Okay, this is true. 0 to 6, right?
Oh, 6.
Or, if Lily wants to, and I prefer this one, it's x is in the interval from 0 to 6. That's a 0.
I like that. But
Same thing. They mean the same thing. Pick your preferred notation. Do you like the inequality or in this interval? No.
Same difference.
Right. Which do you prefer though?
Tomato, tomato.
Same difference.
You don't care?
or tomato.
Okay.
1.
All right. Here we go.
What is the range?
No. Do you want to tell me the range?
No, but I was just hoping that would be
Oh. I'm not gonna ask. I'm not gonna write it. But what's the range?
1 to -1.
Yeah. Negative. Yeah. Okay. Next one. I want to know, what are the critical numbers?
1,
Did you have to
3,
put this question in
5,
there?
and 6.
Like, come on now.
Yes, I did. 1, 3, 5, and 6 is not correct.
0, 1, 2.
Okay. What's a critical number? How do you find a critical number?
Oh wait, no, I was wrong.
F prime. Find f of
Between
x.
1 and 3,
Derivative.
and between 5
You
and 6.
find the derivative f prime.
So f prime prime.
So it's
No,
0.
No. Critical numbers are just f prime. You
So
said it
it's
equal to
already,
what?
it's already differentiated.
This is the derivative. Yep.
Yeah,
It's 1
so
and 0, right?
Between 1 and
Look
3.
at the graph. Do you see any values where the derivative, the graph we have, is 0?
Between 1 and 3.
Between
No.
1 and 3? Here?
And then
At 0.
At 0.
5.
Ooh, but is it defined here?
No, so at
No.
4.
4.
No critical.
There is a single critical number at x equals 4. Because this is where the derivative is what? 0. Critical number at x equals
Dang,
4.
It's so much easier when you have a graph.
Hmm.
Well, finding the critical
I don't know if I agree with you.
You can just look at it.
Finding the critical.
All right, the third question. I want to know at which point, when, does f of x have a horizontal tangent, which I'm going to call that Horton.
You're right.
Horton Here's who?
I don't know how people have first period math. Oh my god.
You took a first period math class.
No, we
No,
didn't.
we didn't. We
We
had
had
a
a
second
second
period.
period.
We had a
Second.
6th period.
We had first way more fun.
I doubled up and I didn't have first period.
I don't mind first hour math class.
I'm glad I'm in.
Yeah.
I'm struggling right now.
All right, when does f have a horizontal tangent, a hortan? There's no w, there's no joke in there. Oh, I see. Okay.
Oh my
All right.
god.
When would the graph of f of x have a horizontal tangent line?
Wait, horizontal.
At
What?
why
At 0.
4?
At 0.
Horton.
Why? So Lily, I'm gonna make you elaborate. Why? You said 4, right? Why?
Well, I don't know. Because it's
Different.
going
Well, I would say
Fortune here's
Is it defined as 0 though? Okay. 0's an issue, right? Okay. Think about this. If you wanted the tangent line to be horizontal, what would its slope be?
Oh, I was thinking of
0.
asymptote.
Yep. You would want it to be 0, right? Now, This is the graph of what?
The pi.
F prime. What does F prime give me? What about the tangent? The slope of the tangent. When I ask, when does f of x have a horizontal tangent line, I'm really asking, hey, when is the value of f prime of x equal to 0? Nope. What's the value of the derivative here? On this whole spot? It's -1. It's not 0.
Oh, so 4.
You're going a step further. Right here is the only place where the derivative is 0. Cool. The only place that f of x has a horizontal tangent is at x equals -4. Now, I will tell you the most common mistake. -4, weird. 4. Sorry. The common mistake with these problems is people are going to try to say here and here, those intervals. Because you're looking at this and you're thinking, what is the slope of the line here? But this is the derivative already. Okay, when is the derivative 0 is the same question of when is a horizontal tangent line. All right. Nope.
We have 8 on this, right?
Yep, there's 8 of them. My next question is, when does 1025, when does x, or f of x, have a vertical tangent? You can call it Burton if you want to. Okay, and I'm actually going to go ahead. I'm going to leave a little bit of space, and I'm going to give you the other 3 questions. I want you guys to talk about them with each other, and then we'll come back together.
Would that be the endpoint?
Does f have corners?
Yeah. Or no.
Corner is a sharp turn. Okay, 6. Where is f increasing? 7. Where is f decreasing? And I'm sorry, I'm at the bottom of my page, is why I'm squishing these all together. 8 is where is f constant? Okay, I'm going to pause this. I'm going to give you guys a couple minutes to talk these out. Let's chat them out. Random numbers. We're just going to go through everybody. Shane. Vertical tangent?
There are
None. Why?
Yes. Just kidding, I didn't say that.
no graphification.
Can you tell me why you think that, Shane?
Because there's no point where it's undefined.
Perfect. A vertical tangent means that the slope of that tangent line is undefined. There is no portion in this interval where it's undefined. There is no vertical tangent. If this had been an open circle, instead, there would be a vertical tangent at 5.
Why doesn't it count as 0?
Because that's just the domain of my function. I'm only looking at the open interval. Okay. Everybody cool with that idea? Who said no? Okay. It's not helpful. Probably keep it to yourself. Corners. I think I know somebody in here is almost undoubtedly going to say at 1, at 3, and at 5. Because you look at the graph and you see there's corners of that thing at 1 and 3 and 5. Totally get it. However, I'm asking about what?
Corner.
Of f. What do we have?
The
F prime. So here's what I was going to start talking about. And Tristan, I think based on your eyes when I made this comment, I think you realized it. Let's consider any function that has a corner. I'll just consider the most basic. That's absolute value of x. Okay. What would the derivative be here? It's -1, right? What would it be over here?
1.
Which means when you graphed the derivative, f prime based on this one, you would see a function that does this. Are there any jump discontinuities on this graph? No. And because there are no jump discontinuities, does it have any corners? No.
Well, 4 was
None.
a trick question.
All right, I think 6 and 7 are also kind of tricky questions. Okay. Shaw. Where's f increasing? I assume you're gonna say an interval, right? Or did you say a point?
I said, well, I said a point, but the interval is like 3 to.
Who else has 3 to 5?
Open bracket.
Oh my gosh, I can see so much why you have 3 to 5. If my question was when is f prime increasing, I agree. 3 to 5 it is.
Oh my gosh.
Totally agree with you. F prime is increasing on 3 to 5. However, I'm not asking about f prime, I'm asking about f. A function f is increasing if what's true about its derivative? It's positive. Are there portions here where my derivative is positive? Not the slope of my derivative, just the derivative.
4 to 6.
From 4 to 6, all these values, my derivative is positive. Okay, f is increasing from 4 to 6.
Decreasing in 3 to
4 to 6, my function is increasing. Okay, decreasing. It's where the derivative is what?
4.
Negative. On which interval does this function have negative values? 0 to 4. Okay, this last one's kind of just a curveball. When is f constant? At one particular point, x equals 4. Now,
I did this so wrong.
no, these are hard, like, Jadri, when you said, oh, the graph problems are so much easier. Depends. If you really, truly keep this in sight that it's f prime, I think they can be
Oh
easy.
my god, that made me so mad when you said F, not F prime.
Yep, no, it happens. That's a common mistake. All right, yo.
Why is it open?
Because at this point, what is the derivative? So if I had a tangent line that has a slope of 0, I wouldn't really say it's increasing, but I also wouldn't say it's decreasing. Now, your book, and I hate only like 2 or 3 things about your book that I dislike, they use both of them. Sometimes it'll be open in the book, sometimes it'll be closed. In my head, I don't think closed makes sense though, because if its slope is 0, it's not increasing. All right, do you want to do another problem together of any of these types? Mean value theorem? Increasing, decreasing? Okay, you guys got 40 minutes. Yeah. All right, let me give you the assignment.
We actually go to the
Go to the chiropractor.
What?
We'll be back.
Have scoliosis.
You guys both going to the bathroom? No.
No,
Okay.
we'll
Me
go
too.
to Tiffany's Cafe and get some food and some drinks.
Do you work over there?
No.
No? Okay.
That's like a one-person job.
Yeah. All right, we're in Calc, huh?
No, we're in algebra 2.
We're in math class.
Dude, algebra 2 is my favorite math of high school.
I'm.
That'd be really silly.
I gave every other class a packet to do.
I promise you, nobody's gonna do it.
Every other class.
I made it worth a
different
20-point
for
homework.
calculus. You have an 8
It's, I didn't give you guys a packet
Why?
because I forgot to print it.
Oh.
I can print it right now.
Yeah, it's okay.
We're in honors. I just realized that we probably wouldn't have got one this.
Okay, I don't think you need a packet because this will probably take a while. I'm hoping that 40 minutes because it's 2 assignments.
Whoa. Man, I don't want to bring my textbook.
Take a picture. All right, page 309. This is longer than normal, I'll tell you. I'll make this one worth 10 points, so it's a double homework assignment. You have 2 weeks to do it. Do as much as you can over 40 minutes, and then do a problem a day. You'll get it done. I want you to do 21 through 29
Homework
odd.
4.3. Mr. Bowie, you skipped the whole beginning part.
Homework 4.3, page 309. Sorry, you're right.
And you get the privilege of working.
Yeah, you get the privilege of working problems 21 through 29 odd. 37. 45. 47. 49.
Why didn't you just do
Yeah, I'm seeing that now. And I want you to do AP 1 through 6.
Not too bad.
That's not bad. Wow, so now we're gonna look at it. Each thing has like 20 parts.
I don't think so. I mean, I don't know, but I don't think so. Okay, other thing I think I want to start doing. I think like a real sign of do you understand it would mean that you could teach somebody. I think we're gonna start doing presentations. We're, really? Oh. So I typically do them in Calc. First semester was weird, obviously. Yeah, we'll pick up presentations, probably a couple a month. They'll be small group, so that you don't have to panic in front of the whole class. And you guys will grade each other.
On how we
Give us
teach
another would be
guys.
great.
Yep. Okay.
We are family, guys. Remember?
Cool. 40 minutes you guys have right now. 35 minutes, I guess. What? 25 minutes. I can't math. Get started. Ask questions because I'm here. No packet over the week break. Cool. Sam and Ava. Hi. Merry Christmas. Happy holidays. Happy Hanukkah. Happy Kwanzaa. I don't know any others.
Chinese New Year and Merry Christmas.
Happy Chinese. Well, Chinese New Year is.
February.
Yeah.
Yeah.
Ciao.